For the following logarithmic functions, find the equation of the asymptote, graph the function, the domain, and range. Okay, so starting with the basic logarithmic graph. The basic logarithmic graph has a vertical asymptote at 0. One point right in front of the asymptote is where the graph passes through. It approaches the asymptote as you go to negative infinity, and then just kind of grows slowly as you go to positive infinity. Now, the 8 right here on the inside of my logarithm, this is going to be a horizontal shift. It's going to be 8 units going to the left. So that vertical asymptote that would have been at 0 starts at negative 8. So I'm going to draw vertical asymptote right there. And for part 1, it says, what's the equation of the asymptote? Well, it's a vertical line, and that vertical line is at negative 8. The equation of a vertical line is x equals some constant. Now the graph of the function, so there's no other changes to this graph. There's no vertical shift or anything else. So that point that is 1 unit in front of the asymptote is still going to lie on the x-axis. If it was a vertical shift, it could go up or down, but there's none. So my graph approaches the vertical asymptote and then kind of grows slowly as you go to positive infinity. And there's a decent sketch of that graph. So part 2 is the answer to the graph, and then part 3, we want to know what the domain and range is. So just from the graph, the domain is everything along the x that's defined. So we're definitely not defined for the asymptote, but there is part of the function everywhere else on this x-axis that's on to the right of the asymptote. So the domain is effectively negative 8 to positive infinity. The range, if you smash everything up against this graph up against the y-axis, you're going to get something everywhere. It looks like here that the graph isn't growing very quickly, and that is entirely true, but it certainly will grow quick enough that eventually it'll get to positive infinity. So the range is negative infinity to positive infinity.